Hey everyone, 4.4 picks up where we left off yesterday. So yesterday we were proving these identities. So we had an equation and we knew what the other side was supposed to be equal to. Today, the difference is that now we only have one side of an expression here, and we're going to have to simplify it as much as we possibly can in order to get what the other side of the equation may have been equal to, like we were doing in problems from yesterday. Okay, so you see it still has these trig expressions in it. Okay, we're still going to be using our identities, so you might want to pull out your formula sheet. Okay, and we're just trying to simplify this as much as possible without knowing, well, what is the other side of the equation? So the first thing that I notice here in the numerator of the problem, I have a difference of squares. Okay, remember, you're trying to simplify, and I know, well, if I factor that as a difference of squares, even using a u substitution if I need to, that's going to allow me to cancel with the expression on the bottom. Okay, so the top factors as cosine plus 1 and cosine minus 1. So the reason that I did that, instead of changing it into a Pythagorean identity, well, the signs, SIGNs, weren't really working with cosine squared minus 1. So if you refer to your trig identities, it would really be 1 minus cosine squared, okay, that is equal to sine squared. So that's one reason that I kind of went this route. But I also saw, okay, well, I'm trying to simplify this. And if I do difference of squares, well, now I can get rid of those. And I'm left with just a cosine plus 1. There's nothing more that I can do to simplify that. So that is fully simplified. Okay, moving on to our next one. Now I see 1 minus sine squared. That actually is a Pythagorean. So 1 minus sine squared, I can change to a cosine. And in the denominator, a cosecant squared minus 1, well, that's a cotangent squared. So I could change each of those using the Pythagorean identities. Okay, so cosine squared, I'm going to leave that because cotangent squared, I know that I can write that in terms of sine and cosine. So I'm going to make that a cosine squared over a sine squared in the denominator of my problem. And whenever I have a complex fraction like this, keep, change, flip, and multiply by the reciprocal. Okay, which is now allowing me, I can cancel, and this whole thing will fully simplify to a sine squared. Okay, and that looks much more simplified and much better than our original equation, or our original expression, rather. Okay, so if you saw this problem, hopefully your first instinct is to FOIL. So we get 1 plus sine of theta minus sine of theta minus sine squared theta. Okay, those middle terms are canceling because those are really difference of squares factors. So now I have 1 minus sine squared theta. Okay, and again, hopefully we recognize 1 minus sine squared is a Pythagorean. Okay, and we can simplify that much more to just be a cosine squared. That would be fully simplified for this one. Okay, if you take a look, you want to combine, your factoring skills that we did in 4.1 as well as our identity skills. So I see that this has a GCF of cosine squared. I could take a cosine squared out of each term. So I would be left with sine squared plus a cosine squared. Well, again, Pythagorean's coming up big today. Sine squared plus cosine squared. That's just 1. Making this simply a cosine squared. Right? 2 more. We're almost done. So see what kind of expressions you have in the problem. Always try and condense, make them smaller when possible. So I see this secant squared minus 1, and I know that if I rearrange one of my Pythagorean identities, that this equals tan squared. And I think this would be a good time to turn everything into sines and cosines because it can all be written that way. So hopefully some things will cancel out. Okay, remember that the basic identities apply when things are squared. So a tangent squared is a sine squared over a cosine squared. So I can do some cross canceling. This sine on the bottom will cancel with 1 from the top, and this cosine will cancel with 1 from the bottom. So we're left with a sine over cosine, which is just tangent. You know, you may find alternative ways to do some problems, and that's perfectly fine. It doesn't matter which identities you use because we know some of them have multiple equivalents. You could still get to the same final answer. So as long as the identities are appropriate and they're equivalent, you could get there using another route. All right, the last one. This one's big. So what I'm going to do here is work on my numerator and my denominator separately. So I'm going to split this up. I'm going to work on the top over here and the bottom, and then we'll just put them back together. So in the top, okay, I have 1 plus tangent squared and then secant squared times cotangent. So I think I'm going to change the secant squared and the cotangent squared first. Since they're using multiplication, maybe I can simplify. Okay, and I can cancel out those cosines. Since I'm going to have a sine squared in the denominator, I'm going to change that tangent squared the next step. All right. So I'm going to make a common denominator out of the 1 and the sine squared over cosine squared. So when I do that, I'm going to get cosine squared over cosine squared. And I want to do just that because only make a common denominator out of those two, because now I see, well, if I put these two together, I have a Pythagorean identity. Cosine squared plus sine squared equals 1. So when I combine this fraction, I can make this 1 over cosine squared. Okay, so I'm probably going to make a common denominator again here. Oops. Sine squared, sine squared. So again, a sine squared plus a cosine squared, I have a 1 over a sine squared cosine squared. So I'm going to leave it there for a minute. That's just the numerator. And let's work on the bottom. So in the bottom, I see that both of those terms, I could take out a GCF. And I'm going to refer to my Pythagorean identities because 1 plus cotangent squared is a cosecant squared. I'm going to leave those the way they are for right now. And let's get some more room. We're going to put all of this back together. So I have 1 over sine squared, cosine squared, and in the denominator, I have 2 cosecant squareds. Okay, well, the numerator is in terms of sines and cosines, so I'm going to change the denominator to be in terms of sine and cosine. Each of those is a 1 over sine squared. Okay, complex fraction, we're going to keep, change, flip. So I'm multiplying by the reciprocal. Okay, and I see that I can cross cancel. So what am I left with? A sine squared in the top and a cosine squared in the bottom, which equals a tangent squared. Okay, so that would be my final simplified answer for that. Now you could have gotten there maybe much more directly, maybe taking less steps. These are just the identities that I saw first, and that's what I went with. Okay, again, as long as you get to the same fully simplified answer of tangent squared and you are using mathematically appropriate techniques and the correct identities, you can get there using a sequence of different steps.